Our last method is called the quadratic formula. So when do we want to use the quadratic formula? In my opinion, it's a last resort method. If you can factor, definitely factor it. If you can take the square root method, do that. If a is 1 and b is even, then do completing the square, because then you won't have any fractions. But if none of those seem like a good option, then your last resort would be to use the quadratic formula. The steps are: put the quadratic formula in standard form, meaning all the terms on one side and it equals 0 on the other. Then I want you to find the values of a, b, and c in the quadratic form ax squared plus bx plus c. Please note that a, b, and c are the numbers in front of the variables. So not x, I'm just talking about a, b, and c, like 2, 7, 5, some numbers, okay? And then I want you to substitute those values for a, b, and c into the quadratic formula, which is this quadratic formula right here. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That is the quadratic formula. You should put boxes around it or stars. Something is very important, okay? In order to do this, you have to have that formula. Step 4 says to carefully do the arithmetic under the square root sign. So there's a lot of things under the square root, b squared minus 4ac. You need to carefully do that using your PEMDAS. Step 5 says, if possible, I want you to simplify the radical. Step 6 says, if possible, I want you to reduce the fraction. Okay, so in order to be successful when using the quadratic formula, you have to memorize the formula. And I know that seems like it's a lot, but let me show you one thing that might help you out.
This is the quadratic formula. X equals negative b plus or minus the square root p sub minus RAC over 2a.
And if you weren't impressed by that one, let's check out this one.
X equals negative b plus the minus square root b square minus 4ac over 2a.
So they were 3 and 5 years old at the time, so I think you can memorize your quadratic formula. Okay, so let's practice these. On our first step, we have, is it in standard form? Is it already equal to 0? Yes, it is. Step 2 says find the values of a, b, and c. Now some students will skip this step and they can just say, oh, I can see a, b, and c off the formula. I might not skip it, especially with the negatives. It might make some mistakes. So a is equal to the number in front of x squared, which is 1. b is equal to the number in front of the x, which is negative 4. And c is equal to the constant term, which is just negative 1. Step 3 says substitute the values into the quadratic formula. Now, in order to memorize the quadratic formula, other than that cute little song I just showed you, one method would be to write it out every single time that you do a problem. And if you write it out every time, then hopefully by the end of your lesson, you'll have it memorized. So we have x equals negative b. Now, b is already negative 4, so I'm going to take the opposite of negative 4 because that has the negative in front of the b, so that's actually positive 4. Negative 4 is positive 4. Plus or minus the square root. So we have b squared. Please chew this b squared in your head. If you write negative 4 squared, then you might be tempted to write negative 16. But if I just ask you what's negative 4 times itself negative 4, you know it's positive 16, okay? So please be careful and just do that part in your head. It avoids error. Minus 4, because there's a 4 in the problem, times a times c. Now my a is 1 in this problem, and my c is negative 1, all over 2 times a. Notice the all over, the bar goes all the way from the 4 in the front to the end of the radical sign, all over. All right, on the next step, it says to carefully do the arithmetic inside the square root. So we have 4 plus or minus, and then we have all this junk in here. I'm going to take 2 steps to do it. 16 minus 4 times 1 times negative 1. A negative times a negative is a positive. 4 times 1, that's just 4. And that gets me 4 plus or minus the square root of 20. So I carefully worked out the underneath the radical. Step 4 says, if possible, simplify the radical. Okay, let's see if we can do that. 20, that's 4 and 5, 2, 2, and yep, okay, this works. So that's 4 plus or minus 2 square roots of 5. And then the last thing says simplify the fraction. Now, in order to simplify the fraction, all of the numbers outside the radical, the 2, the 4, and the 2, all have to have a common factor. So the appropriate way of doing this is to factor out a term out of the numerator. So I'm going to factor out a 2. And then now that you can see that 2 and the 2 in the front, because this is a multiply here, I can divide that out nicely. And so my final answer is 2 plus or minus the square root of 5. Now, some students will take a shortcut, which is fine by me. Just don't make any mistakes if you do that. What they'll do is they'll take the 4, the 2, and the 2, and they'll say, okay, all of the numbers outside of the radical can be divided by 2. So they'll just divide it by 2, divide it by 2, and divide it by 2. And they'll get this answer a little bit faster, which is fine by me, but I'm going to continue to show you the appropriate way of factoring it, because mathematically that's what you're really supposed to be doing. On our next problem, is it in standard form? Yes. So it does equal 0. Great. What's my A, my B, and my C? Looks like A is positive 9, B is negative 18, and C is positive 7. I'm going to write out my formula because I'm trying to memorize it. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Next, I'm going to carefully substitute all of that in, so x equals negative b. Well, b is already negative 18, so the opposite of b is actually positive 18, plus or minus the square root, b squared. 18 squared is 324, minus 4 times a, which is 9, times c, which is 7, all over 2 times 9. So next step is to carefully do the arithmetic underneath the radical. So 4 times 9 is 36, and 36 times 7, I don't know what that is. 72, 252. Okay, so I have 324 minus, because there's one negative, times 2 more positive, that's still a negative, 252. So 324 minus 252 is 72. And now I've done the arithmetic under the radical. My next step says to carefully simplify the radical. So if there is 72, let's see if I can break that down. 8 and 9, 4 and 2, 2, 2, 2, 3, and 3. So I have a group of 3 and a group of 2. So the 2 and the 3 come out. And that leftover 2 stays at home. So that's 18 plus or minus 6 root 2 over 18. It looks like I can factor my numerator. I can take a 6 out. And 18 and 6 can reduce to a third. So my final answer here is 3 plus or minus the square root of 2 over 3. Notice again there's still 2 answers there. Alright, on our last problem, step 1, is it equal to 0? Well, it is not equal to 0, so I need to make it equal to 0 by subtracting or adding the terms to make them all on one side, which will get me x squared plus 6x plus 13 equals 0. So a is equal to 1, b is equal to 6, and c is equal to 13. I'm going to write out my formula to help myself memorize it. B squared minus 4ac. Don't forget that all over goes all the way back from negative b all the way to the square root. So x equals negative b. b is 6, so the opposite of 6 is negative 6, plus or minus the square root. B squared is 6, so 6 squared is 36, minus 4 times a times c. My a is 1 and my c is 13, all over 2 times 1. Hmm, 13 times 4, that's 52, so we have 36 minus 52 under the radical, which gets me negative 16. Now the square root of negative 16, that's going to be 4i, because the negative makes it an I. It looks like I can factor a 2 out of the numerator, which gets me negative 3 plus or minus 2i. And the 2 in the numerator and the 2 in the denominator, now that the operation is multiply, can divide out nicely. And so my solution is negative 3 plus or minus 2i.